For the very first two problems, all they say is evaluate. They have given us a number right here to plug in. If they tell you to find f of -2, they want you to plug in the -2 where the x is. So all you have to do is this. Put your -2 in parentheses because you're squaring it. And then you guys need to type in that side to the calculator and figure out what it is. Yeah, because it would be 4 minus 3, which is 1. So f of -2 equals 1. Yep. Now number 2, same type of problem. You are plugging this -4 in where you see the x. So far all I've done is I have rewritten this right side with a -4 where the x was. So now we got to figure this out, okay? So talk this through with me because you guys can't type in absolute value into your calculator. Now you can type this part in. So can you look up here, please? You guys could type this in, like -3 times -4 minus 14. And that'll give you -2. And what is the absolute value of -2? Positive 2. So positive 2 is the final answer. Okay, so those are just plug and chug problems. You are plugging, yes, you are plugging numbers in and then just letting basically the calculators do the work. All right, now the next section down here at the bottom, this is like what we were kind of doing today on the do now. They have given us two functions and they want us on this one to do the subtraction. This one we're going to multiply them and this one we're going to divide them. And notice how they all have the letter x right here. So they have not given you a number to plug in. So you're not plugging in any number. All you're doing is exactly what it says. On the first one, we're going to subtract h and g. So h, now look, order matters with subtraction, right? H is this one. So start with 2x squared minus x. You put that down first. Then you put a minus sign, and then g would go in the second set of parentheses, which is 2x minus 4x squared. What do we do every time we have subtraction? First, what do we do? Keep, change, change. So keep, change, and then both of those change as well. And then you guys can combine like terms. So I have 2x squared plus 4x squared. We have a 6x squared to start with. And then we have a -1x plus a -2x, which is -3x. So that problem was keep, change, change, then combine like terms. That's what we did there. Combine, or keep, change, change, because it was subtraction, and then combine like terms. Now number 4 says to multiply them. Well, if you look at your two expressions, they both have two terms, correct? So we're making a 2 by 2 box. And multiplication order does not matter, so I'm going to do the 2x squared minus 1x up top, and then the 2x minus 4x squared on the bottom, or on the side. It doesn't matter, it's multiplication, so you're going to end up multiplying all the same stuff. Just set it up however you want. All you have to do, though, you better watch those exponents. When you multiply the numbers out front together to make 4, and then x times x squared is x to the third. And then 2 times negative 1 is negative 2, and x times x would be x squared. Then the bottom row. Negative 4 times 2 is negative 8, and then x squared times x squared is x to the fourth. And then negative 4 times negative 1 is positive 4, and x squared times x is x cubed. Okay, so once you guys have those 4 terms, the way I list mine out is I always put my highest exponent first. Now, does it have to be that way? No. I just prefer to start with my highest exponent. Then if I go to my cubes, aren't there 2 of them with x cubed? So that's a total of 8x cubed, so plus 8x cubed in the middle, and then minus 2x squared at the end. Okay, so that was your multiplication problem. All right, now for division. Order matters with division, yes? So if it has G listed up top, you guys have to make sure you put G up top when you set this up. So I would have 2x minus 4x squared up top, and then H, which is 2x squared minus 1x on the bottom. Now, because this is a fraction and they still have an x here, all we can do is factor and cancel stuff out that matches. So for 2 and 4, what do they both have in common?
X's. Oh.
A 2 and an x. It both, right? They're both divisible by 2 and they both have an x. So 2x is the GCF that you bring out. And then in parentheses, we would have a 1 minus 2x left over. Because I divided 2x by 2x and it left me with a 1. Negative 4x squared divided by 2x is negative 2x. Okay, so that's GCF for the top. Now on the bottom, what do these two have in common? Just an x, right? Okay, so if you take an x out of each term, what would be left? 2x minus 1? Okay, now this is what I want you guys to look at. This is kind of a pain, but do you guys see how this set of parentheses almost looks like this one? But the difference is the signs are backwards. So watch, just watch. If I take a negative out here, if I take a negative out of this and just move it out front, this would become negative and that would become positive, and now don't those two sets of parentheses match each other? Yes. You're allowed to do that. You're allowed to do that at any time. If the two sets of parentheses are almost identical except the signs are backwards, just take a negative out and change their signs, because now this is what I can do. I can cross these two out, and isn't there an x I can cross out right here with this one? So the only thing left is a negative 2? There you go. That's how it simplifies. Now, they don't always simplify like that. You know, they simplify in different ways, but whatever cancels, cancels. Now, those three all had the letter x in parentheses, which means leave it in terms of x. You don't have a number to do like a plug and chug with. So the next two do have a number to do a plug and chug with, correct? So like number 6, they want us to do g plus h. So they want us to do this. Here's g, 2x minus 4x squared. And they want us to add h, which is 2x squared minus x, to it. However, they want us to plug in the number 2 wherever you see a letter x. So this is what I'm going to do. Can you guys watch? I'm going to do this set of parentheses separate from this one. I'm going to plug in a 2 and let's see what happens. So if we do 2 times 2 and then minus 4 times 2 squared, that's the first set. I need you guys, so follow along with me here. We would have to start with exponents first. What's 2 squared? 2 squared is 4 times 4, and then 2 times 2 is 4. So what's 4 minus 16?
12.
Negative 12. So that whole first set of parentheses just becomes a negative 12. And I'm going to bring down this plus sign. And we need to figure out what this one over here would be if we plugged in a 2, wherever we see the letter X. So I plugged it in here and there. Just plugged in a number 2. Yeah, so 2 squared is 4, times 2 is 8, and 8 minus 2 is 6. So, final answer, negative 12 plus 6 is negative 6. And then last problem on the front, number 7. We have h divided by g this time, so it's not g divided by h, it's h divided by g. So make sure when you set it up, h goes up top, g goes on the bottom. And now what do they want me to do? What number am I plugging in? Okay, so wherever you see x's, and there's lots of them, you're plugging in a negative 1. So I'd have 2 times negative 1 squared minus a negative 1 up top. And on the bottom, 2 times negative 1 minus 4 times negative 1 squared. Now, if it were me, I would just pick up the calculator and type in the entire numerator, get an answer, tell me what it is, and then I would type in the entire denominator into the calculator, get an answer, and tell me what it is. You guys have to do that stuff. Type it into a calculator. Mm-hmm. Negative 6. Okay. Now, if you have one positive and one negative, isn't it negative?
Yes.
And what is 3 over 6 reduced to?
1/3.
1
1/2.
half. Yep. So your answer is negative 1/2. Now you could have just typed into your calculator 3 divided by negative 6, and it would have given you negative 0.5. But, I mean, it's a fraction, so I just reduced it. It doesn't really matter. All right, when you guys are done with that one, go ahead and turn the page. Eight through 11 are all composite. So for number 8, look at which one's in the middle here, G. G is the one that they want you to use as the input. So I'm going to take this, that negative 4x, and I'm going to plug it in right where that x is up top. So I'm taking x out and putting negative 4x in its place, but everything else up top stays the same. So you have 4 times negative 4x minus 5. What's 4 times negative 4x?
Negative 16.
And then the minus 5 is just hanging out by itself. So what's my answer? Letter A. And then for number 9, they want us to plug G into F, where that N is. So originally, this is what I had. I had a negative 3N, but I'm taking N out and putting what in its place?
2n squared minus 2.
Well, the negative 2n squared minus 2, yep. And then I'd still have that minus 3 at the end. Like, you can't forget about the rest of the function f. Okay, so we'll distribute and then we'll combine. So what's negative 3 times negative 2n squared?
Negative or 6n squared.
And then negative 3 times negative 2?
Negative or 6.
Positive 6, and then we have a minus 3. So what's 6 minus 3?
3.
There you go. 6n squared plus 3 is our final answer, which is letter C. Number 10. Which one am I plugging into the other?
You're plugging G into H.
Yep, G is going into H. So instead of 2x minus 1, it would be 2 times 4x plus 2 minus 1. So distribute and combine.
8x plus 4.
Minus 1. Yep. And so what's 4 minus 1?
3.
So it's 8x plus 3. Last one before we do inverses. So number 11, watch. There's a number here. They want us to take G once we plug in a 5, and we're going to plug it in up here to H wherever there's a letter T. Okay, so we have, I need to work this one out first. I need to plug in a 5 next to the 2. So I would do 2 times 5 minus 4, which is what? Okay. So now the 6, so I simplified G, made it a 6. Now the 6 is what we're going to plug in here and here. So I would do 6 in parentheses squared minus 3 times 6.
36. Isn't that 16?
Minus
18.
18, which is
20.
Too big.
18.
18. Yep. So those are all your function operations. So again, function operations, which were problems 3 through 11. All those problems that we just did, that really big section of problems that we just did. That's the first lesson I taught last Thursday, function operations. Okay, inverse functions that are down there at the bottom, we did like the day before that, or maybe the day before that, I can't remember. All the days have run together now. But inverse functions down at the bottom, remember step 1, what do you put where the f of x is? What letter? F of x is the same thing as y. So we are going to plug the y in. You guys are going to replace this with a y always. That's step 1. What's step 2? Step 1, you put a y in. Step 2, what do we do? What do you do with the 2 letters?
You put them together.
No.
Multiply them.
You divide it.
Square root. Oh, you. Square root.
What do I do with the x and the y? Oh, goodness gracious. You trade them. You just switch them around. Everything else stays where it is. You just trade the 2 letters. Our goal with inverses is to undo this. Whatever we started with, we should end with a function that has all the inverse operations. I see a -3. At the end, I should see a +3. I see a -2, so at the end, I should see a +2 somewhere. And right now, I see the cubed root, which means at the end, I should see the 3rd power. Okay? So our goal at this point is to get y by itself. So what number can I move?
2.
I can go ahead and add 2 to both sides. So I have x plus 2 equals the cubed root of y minus 3. Now we cannot move the -3 because it's under a root. What's the inverse of roots? I just said it.
Square root. Oh, wait.
What did I say we should end with? Not the cubed root, but
To the 3rd.
to the 3rd power. So you raise this side to the 3rd power to cancel out the root. And if you raise this side to the 3rd, you've got to raise the left side to the 3rd. So on the left, we have x plus 2 in parentheses to the 3rd power. On the right, what is left? Because this power cancels out this root. Y minus 3. And what's the last thing I do?
Flip it.
What can I move now?
Oh. The y minus 2.
Add 3 to both sides. Can you combine the 3 with the 2? No, the 2 is in parentheses with an exponent. All you guys do is write this sideways. And instead of putting equals y at the end, what's the inverse notation?
0.
And there's a -1 right there as the exponent. I know a lot of you guys were here. We did inverses like 2 days. Last week. Tuesday, Wednesday. And I know a lot of you were here. That is how you do every single one of these. You put y in, you trade x and y, and then you do whatever operations need to be done to get the y by itself. So this one I would start with y equals x plus 2 to the 3rd plus 3. Then I'm going to trade x and y. And then you guys are going to have to tell me what to do to get y by itself. So I'll just wait for you guys to give me my steps. I already did that. So I put y in and I traded x and y.
Okay, subtract 3 from both sides.
Subtract 3 from both sides, yep. So we're going to subtract 3. So I have x minus 3 on the left and y plus 2 to the 3rd on the right. Now what? No, it's a root, just not square root.
Multiply 3.
Cubed root.
From both sides.
We're going to do cubed root because that's the inverse of the cubed, like power of 3. So now on the left, we have the cubed root of x minus 3. And on the right, what do I have? Y plus 2. Because the power and the root cancel each other out. And there's only one more thing to do.
Subtract 2 from both sides.
And it will not pair up with the negative 3 because the negative 3 is under a root. So you just write it all sideways. Cubed root of x minus 3. The minus 2 should not be under the radical. And then instead of putting equals y, go back to your inverse notation, your function notation. F of x, and it has to have a negative 1 as the exponent between them. Is it all coming back to you now? Fourteen's way easier because there's no root, there's no power. So I've put y in and then I traded x and y. Now what?
Subtract 1 from both sides.
Subtract the 1. I have x minus 1 on the left, and on the right I have negative 1/2 y. How do I get rid of the denominator of 2? We're going to multiply both sides by 2. Now look, the right side here, hope you're watching, this cancels this. So on the right side, I have a negative 1y. On the left side, though, if I have to multiply this whole thing by 2, shouldn't I do that? Like, shouldn't that be in parentheses? Because I'm going to have to distribute it. So that'd be 2x minus 2. What's my last step?
Add 1 to this.
They didn't subtract 1.
Add 2.
They did not subtract 1, which means what?
Oh, the
No.
You add 1. Subtract 1.
You guys, when these are,
Divide,
thank
divide.
you, goodness gracious. When they're side by side, that's multiplication. We're dividing. So here's our answer. The 2x minus 2 divided by negative 1. And then instead of putting equals y, just go back to your function notation. Notice that it was h this time, h of x. So it'd be h of x with the negative 1 in between them. So those are your inverse problems. That's a whole little section on its own. Because then as soon as you turn the page, we get into what we were doing today. The transformations. No, sorry, 15 and 16. This goes with piecewise functions, what we were doing the second part of class on Thursday. So on 15 and 16, are they functions?
No. Yes.
Well, they're both functions. We know that because a quadratic and a square root, they would both pass the vertical line test. So your answer on 15 and 16 for is it a function? Yes. Now, one of them is a one-to-one and the other one is not. If you've already completed today's assignment from the first half of class, you should be able to tell me which one is one-to-one and which one is not.
Square root is.
The square root is, and the quadratic is not.
So is it a function on the square root?
Okay, so what we just said here, now look, I'm just going to do a little sketch. Quadratics look like this, square roots look like this, okay? So, to determine if something's a function, that's the vertical line test. No matter where I draw a vertical line, it's only going to go through one point at a time. And that's true over here too. So that's the vertical line test. Now, to figure out if it's 1 to 1, we use the horizontal line test, so we go this way. Isn't this blue line hitting it twice?
Yeah.
That's the reason it's not 1 to 1. And then this one over here, if you guys drew horizontal lines, it's only going through one at a time, so that one's a yes, that one's okay. Horizontal line test is how you figure out if it's 1 to 1. Vertical line test is how you figure out if it's a function or not. And then 17 is a piecewise. So we practiced one of these today on the Do Now, and it was the second lesson we did Thursday. Okay? Thank you. All right, so for the graphing portion, this one right here, I'm going to make our T-charts down here. What number are both of my T-charts starting with?
0.
-1. The -1 is the number that they gave us here. It's that point of discontinuity. So one of them will be open, one will be closed. Now, if it's less than -1, so listen, less than -1, look up here, would be like -2 and -3. So that's the one that we're going to do the -2x with. -2x is for all the values less than -1. Okay, so I'm going to do -2 times -1, 2. What's -2 times -2?
-4. Or 4.
And then -2 times -3.
6.
Yep. The other thing I want you guys to look at, this symbol right here does not have an equal sign, which means that this first ordered pair is going to be open. If there's no equal sign, it's open. Okay, so -1, 2, open circle on your graph. Now all the others we're going to make closed. So -2, 4 and -3, 6. So then you guys want to put your ruler down, and remember it starts here. It started at the open circle and then it's going up. So all you guys have to do is draw that part of the line. Start at the open circle and just connect your dots going up like that. Now for the values greater than -1, we use the x minus 5. That's what we're using over here. So numbers bigger than -1 would be 0 and 1. So what's -1 minus 5?
-6.
-6. What's 0 minus 5? 0 minus 5
-5.
is -5. And 1 minus 5,
-4.
-4. Okay, when you go to plot your first one, this one right here, this had an equal sign, so that is going to be a closed circle. So at -1, -6, you're making a closed circle, closed dot. And then 0, -5, and 1, -4. So this one started at the closed dot, and it's increasing to the right. And again, at the -1, because it's a function, both of those cannot be closed. So one of them should be open and one should be closed, and they are, and it's based on the symbol. If the symbol had an equal sign, you make it closed. Okay, now the evaluating part, you guys just have to decide based on the number they give you, which one would you plug it into? Well, where would the number 3 be? Would it be less than -1 or greater than -1?
Greater.
Yeah, so if this one's bigger than -1, we're using x minus 5. So we're just going to do 3 minus 5 here, which is what?
N- -2.
-2. Now, is -5 less than or greater than -1?
Less than.
Less than. So this one over here, we're doing -2x. So -2 times -5, which is what?
10.
10. Now, the only one you have to be careful on is -1. -1 was the point of discontinuity. So which one do I have to use?
The bigger one.
Well, the one that had the equal
Negative.
sign, right? If it can equal -1, we're going to do -1 minus 5, which is
-6.
yep. Now look at 15 and 16 again. How did we figure out if it was 1-to-1 or not? Well, 1-to-1 was just horizontal, right? Okay, so on problem 18, it says, explain what is meant by a 1-to-1 function. Well, a 1-to-1 function will pass the horizontal line test. A 1-to-1 function will pass the horizontal line test. And in parentheses, put this: no repeating y values. The vertical line test is to test if something's a function, and they would have no repeating x values. The horizontal line test is for the 1-to-1, so none of our y values should repeat. We don't have much left. 19 and 20, those are two graphs like we just did today. Two transformations. So why don't you guys go ahead and work on those? Even if you don't draw the picture, tell me what the transformations are on the line while everybody's catching up, and then I'll turn the page and I'll get it written down, and then we'll do the graph. What do you guys think about those transformations?
Left 1 unit, up 2 units.
Yep. Left 1, up 2. Okay, now this is absolute value. So remember, for absolute value, we're doing, I usually do the -2 to +2 for my parent function, because those are just easy. -2 to +2 for the x's. And the absolute value is just the positive version of it. So remember, what I'm doing in green is just the parent function. I haven't started moving things yet. And this is absolute value, so it should make a V, which means your ruler should connect your points. Then all you guys have to do is physically move all 5 points. We're going to move them left 1, up 2. Left 1, up 2. Oops, I just went too far. Ignore this point right here. Left 1, up 2. And then left 1, up 2. Left 1, up 2. And you just want to connect those the same way we did the others. So the pink one is the transformation, and my green one was the parent. Then down at the bottom, since it's square root, for your T-chart, you would just do the 0, 1, 4. If there was a 9 available to us, I'd have you guys do the 9, but there's not. So we're going to just do 0, 1, and 4 for the parent. Now remember, this is the parent function, which is just the square root of x. So what's the square root of 0? And square root of 1? And square root of 4, 2. So you guys can go ahead and plot those points just to have the parent function. Square root should always look like that. Just kind of curves up. And then figure out what your transformation is. Like, what's the shift?
Down 3 units.
So remember, this is inside, so it's the left or the right. So that would be right 3. So there is no up or down. If there was an up or a down, it would be outside of that radical. So now you're only going to be able to move. Well, I think we can move them all 3. 1, 2, 3, 1, 2, 3, and 1, 2, 3. Yep. So the orange one is the transformation. And the green one is the original, the parent. And then we've just got the last page to go. I think we have we have some equations we're going to solve. And then at the bottom, it's just going from one form to the other. So I think I'm going to do 27 and 28 first, just because those are pretty simple. But then 21 through 26 we'll obviously have to do some work for, since we're solving equations. Quite honestly, there's really not a whole lot of room on there to show your work. You might want a piece of paper for 21 through 26, just so you can work them out. I do think the whole back side is blank too, so you could always turn it over and write them on the back. Okay, for 27, when you guys go from exponential form to radical form, that top number represents the exponent and the bottom number represents the root. So whatever my base is, that's what goes in the radical. So the letter V goes in the radical. Outside of those parentheses is your exponent, so the 3. And then the root goes right here. Remember, the root should be in the little dip of your radical symbol. It should not be out front of it. That's all you have to do on that problem. Now for 28, we're going to do the opposite. They've given us radical form, and we're going to write it in exponential. So whatever's under the radical goes in parentheses. That's your base, 7r. Now we need to figure out what our exponent is. Where's that 5 go, top or bottom?
Top.
Okay. What's my root?
2.
2. Remember, when you don't see a root, you're supposed to know that it's a square root, so you're supposed to know it's a 2. So it's just 7r to the 5/2 power. 7r has to be in parentheses. It has to. And 5/2, you guys cannot write your answer like this. If it looks like this on your paper, I'm counting it wrong. This looks like 7r times 5/2. That is not correct. The 5/2 has to look like an exponent. Okay? All right. So those two are pretty much, you either get them right or you get them wrong. Now all these equations at the top. Let's start solving these. If there is a number in front of the radical, they have multiplied, so we do what? Okay, so everybody would start by dividing both sides by a 6. What's 18 divided by 6?
24. Or wait. 8.
33.
3?
Did you say divide?
Mm-hmm. Yep, so I have the square root of v divided by 2 equals 3. Now how do we undo a square root? We raise it to the second power, which means we raise the other side of the second power. What is 3 squared?
6. 9.
9. And now the right side is just v divided by 2. And how do you get rid of a divided by 2? Multiply by 2. So v equals 18. Now you are supposed to check for extraneous solutions, which means I should take this 18 and plug it into the original. So like I would write 18 equals 6 radical 18 divided by 2. So I just rewrote my original equation, plugging in the number 18 where the v was. So now let's see if this actually equals 18. What's 18 divided by 2?
6.
9.
9. And what is the square root of 9?
3.
Okay, so this is what it says. Is 6 times 3 equal to 18?
Mm-hmm.
Yes. So the answer of 18 is not extraneous. That is the correct solution. Remember, you guys are supposed to do that check to make sure it's a correct answer. Okay, 22. The radical's already by itself, so how do I get rid of it? We're going to square it, both sides. Well, isn't x squared just x squared? And the right side would just say negative 16 plus 10x. Now, when you guys have an x squared, that's a quadratic, what do I have to do?
Can you subtract the 16 and then subtract
I add 16, subtract 10x. I need to bring these two over here. Now, those two terms have nothing to pair up with, so you need to make sure you put them in the right order. X squared would go first, minus 10x second, plus 16 last. That's an asterisk problem.
What goes at the top? 16?
Mm-hmm.
Is it 8 and 2?
Yep, both negatives. -8, -2. So in parentheses, you'd have x minus 8 times x minus 2, giving us what two answers? X equals 8, x equals 2. Okay, now watch. In order to do the check for each of these, if I'm checking the number 8, the 8 would go first, equals, and then under the radical, it's -16 plus 10 times 8. What's 10 times 8?
80.
What's -16 plus 80?
96.
And is the square root of 64 8?
Yeah.
Okay, this one is correct. So then I need to check 2. Make sure it's not extraneous. So to check 2, I'm now plugging in the number 2. What's 10 times 2?
20.
And what is -16 plus 20? Is the square root of 4 2? Yep. So both of those end up being correct answers. So there's a check and there's a check, and they were both true, so both of them are correct. You wouldn't have to cross any of those answers out. They're all good. This one, 23, I'm going to work that one out on the back, so I'll come back to that one. I just need more room than that. There's not enough room for 23. So we'll finish, I'll do 24 and then I'll go to the back and do 23. 24 isn't bad because if there's a radical on both sides, then we just simply start by squaring both sides, and all that does is get rid of the radicals. So you'd have -1 minus 2m equals 3 minus 1m. So no symbols anymore, it's just an equation with letters on both sides. How do I solve that?
Add 8 on both sides.
I'm adding 1m. So that gives me -1 minus 1m equals 3. Since I brought m to the left, what do I need to move to the right? Add this one. Yep. So -1m equals 4. And divide by -1?
Mm-hmm.
So m would be -4. Now look, I'm going to do my check down here with the -4. I would, under my 1 radical I'm just plugging this back into the original. You guys can't see it, but I'm plugging it back into the original equation. So I'm plugging it into this one, right here. This one, wherever I see the letter M, I just plugged in a -4. And I'm going to check and make sure that the left and the right sides actually do match. Okay, what is -2 times -4?
Negative
8.
Positive 8. And what's -1 plus 8?
7.
Okay. Now on the right side, what's 3 minus -4?
Negative 1. Positive 7.
It's positive 7. Remember that keep, change, change, guys? Keep, change, change. That would just become 3 plus 4. That's 7. Do those two match each other?
Yeah.
Okay, that one's good. That answer of -4 worked out. All right. Let's go to the back. Well, I'm going to go to the back. X equals, this is number 23. X equals 9 plus square root of 41 minus 4x. Okay. Now, this radical needs to be isolated for me to square both sides. So what number has to move?
The 9.
The 9. And if that's been added, we're going to subtract it. So I have x minus 9 equals the square root of 41 minus 4x. Can I square both sides now?
Yes.
Right side's easy. Squaring that square root just gets rid of the symbol. The left side, however, if you have an expression like x minus 9 and you're supposed to square it, what kind of problem is that?
It's x minus 3.
That's a box problem. X minus 9 squared means x minus 9 times x minus 9. Okay, inside the box you should have x squared minus 9x plus 81. This is just the left side of your equation, you guys. So x squared minus 18x plus 81, that is the left side. You still have this right side that said 41 minus 4x. What do I do with these two?
Huh?
Add 41. Or subtract 41.
And add 4x. You got to bring everything to one side when you have a quadratic. It's got to be set equal to 0 for us to do the asterisk. So x squared minus 14x plus 40 equals 0. What are they?
7 and 4. Negatives and negatives.
Both negatives. So we have x minus 10 times x minus 4 equals 0, giving us positive 10 and positive 4 for now. I need to do a check for both of them. So for the number 10, if I plug it into the original where I have the x's, you would have 9 or 10 equals 9 plus the square root of 41 minus 4 times 10. Well, what is 4 times 10?
40,
And what's 41 minus 40?
1,
What's the square root of 1?
1.
Is 9 plus 1 going to equal 10?
Yeah.
Okay. The answer of 10? Good. Now the answer of 4, if we plug in a 4 where the x's were, so that was here and here. What is 4 times 4? And what's 41 minus 16? Okay. What is the square root of 25?
5.
Okay, look at what that says. That says that 9 plus 5 is 4. True or false?
False.
That is a big nope. That is false. Which means the answer of 4 is extraneous, correct? So when you guys had these two as your answers, you better go back up here and cross out the 4. Because the 4, even though it's an answer to the asterisk problem, like to the quadratic, it does not work for the original problem. That should only happen if you have two answers. You know, if you guys just get one answer, like all the other problems, there was just one answer. If you get one answer, hopefully it's the right one. Hopefully you solved it right. But if you guys get two answers, sometimes you will get two trues, and sometimes you'll get one true, one false. Okay? Is everybody good with 23? We only have two problems left. We have 25 and 26. Okay, 25. We cannot solve this until this 1/3 is gone. So we can raise 1/3, multiply it by what? 3 over 1. Well, times 3, right? And if we raise this side to the third power, don't we have to raise this side to the third power? Okay, so you guys have to figure out what 15 to the third is. It's a big number. You're going to want to use your caret button on your calculator. 15 caret 3. Yep. And now this over here, the whole point of doing this is multiplying a fraction by its reciprocal, right? If you have this power raised to the third power, they just cancel out. And so all you're left with on that side is 5p. And then one more step. Divide by 5. $675?
Yeah.
If that had been raised to the 1/4 power, you guys would be raising that to the 4th power, both sides. If it had been 1/5, raise it to the 5th.
Question.
Mm-hmm.
Would there ever be like different numbers that are like 2 and 5 or just 1 over something.
I mean, even if it wasn't a 1, you're always going to multiply by the reciprocal. So I'd raise this to the same power, and then you guys can do that on your calculator. Like you just do 15 caret, and if it was 5 over 2, you just do 5 ABC2. All right, this very last problem. I cannot do anything with this 1/2 power yet because I have this number that I can move over. So let's move this one first by doing what? We're going to add 8 to both sides. So -2 plus 8 is 6 equals, and now the parentheses that are raised to the 1/2 power, that's now by itself. It's isolated. So now we're going to raise it to what power? We're going to raise this to the 2nd power, which means we're going to raise this to the 2nd power. Six squared? And on the right side, the 1/2 and the 2 cancel each other out, so you're just left with r plus 6. One more step to solve it, and we will be done. Subtract 6. So r equals 30. And that is the last problem on your Unit 4 review.